Good afternoon, everyone. On behalf of Pantech-e-Learning and Saveetha Engineering College, I welcome you all for this particular webinar on FPGA systems. I sincerely thank Department of Electronics and Communication Engineering of Saveetha Engineering College for providing this wonderful opportunity conducting success, this kind of trending technology, so which is known as FPGA, which is currently being processed in many kinds of applications, and many of them are also lagging in this particular knowledge. So here now we are to share that particular knowledge on FPGA systems, and I sincerely thank Dr. Shrikatha S. Nath ma'am for providing this wonderful opportunity, head of the department of ECE. Also, I thank Arun Kumar sir, assistant professor. Also, I thank Dr. Kalaivani ma'am for providing this concern opportunity for Pantech-e-Learning. So I hope definitely everyone is ready to attend this particular session, and therefore let us start. So before starting that, we'd like to introduce ourselves. Pantech-e-Learning has been started in the year of 2004. We have 7 wings and 100 plus team size. So we have our own R&D for industrial design services, lab equipment manufacture, working on funded projects, workshops, FDPs, internship, value-added courses, online training, project guidance. Also, we have conducted more than 2,000 workshops, 300 plus FDPs, and 12.5 lakhs students have attended this kind of different techniques, especially ML, DL, embedded, IoT, and so on. We are also releasing our new technologies. So everyone can stay tuned to this Pantech e-learning channel as well as pantechelearning.com. To get the regular updates and to support your queries, you can follow us on Instagram, Telegram, YouTube, and podcasts. So these are the links, and these links will be available in description box. Okay. So now let us start. FPGA. So generally, FPGA is one of the heart or one of the main core inside a VLSI. So generally, if you go for VLSI, many of them will be separating the particular projects into software and hardware. So that particular software and hardware, it is nothing but the simulation. It is completely done in the form of using the Xilinx IDE or Model Sim. So like that kind of many softwares will be there. But once whenever we go for the hardware purpose, the one and only hardware, it is nothing but FPGA. So there is no any other substance over there. So therefore, this particular FPGA will play a major role for multiple applications for every kinds of electronic devices whichever we are currently using on. Whatever we see, like let it be the modem or the CPU or let it be our mobile phone, everything is nowadays it is in the form of embedded. So like with that particular embedded, we will be able to control that particular any of the appliance, and at the same time we will be able to transmit the signals, transmit the data. So like this kind of many functions are there. But this kind of data or whatever we are transferring, it is quintalized into a miniature. So for that we have to design some sort of arrays. So for that only here we will be using the FPGA boards. Many of them might have seen. If you go for your FPGA labs, means you will be having the different lab kit, and through that you guys will be testing some sort of inputs. So based on that, without any losses, and if your processing is higher speed, therefore that will be the best sort of the board for that particular application. So this is a single board where multiple application can be done, but not at the same time. So that is one of the exceptional cases over here. Why that particular multiple things cannot be done means we'll be explaining whenever we are going to the comparison of microcontroller as well as the FPGA. So once whenever we are going for this particular FPGA means it expansion itself field programmable gate array. So whatever that according to the respective field, for example, IoT is one sort of field, and within that motor controlling or switch based controlling, that is another, depending upon the embedding field. And nowadays MLDL or image processing, that is also different kinds of field. So this all are different fields which we will be able to program inside the chip or design the chip according to its function by using the gate array format. So the gate pulses or that particular allocated gates in a particular system. So from that we will be able to enable each and every section. Okay, so today we will be just completely seeing the complete basic of FPGA. I cannot say it is a complete basic because to understand the basic of a VLSI tools or to get a basic guidance on that itself, it takes around 1 or 2 weeks, because that much elaborated stream this one. So today I will try to cover the maximum area to understand what is FPGA and how a project is created inside the Vivado by selecting a FPGA board. So for that, we are using Zinc 7010. So that particular processor's board only here will be taken. So we'll be also seeing that how the Zinc processor's IP is selected inside the Vivado. So this particular sections we have to compare with multiple functions, and at the same time, what is the architecture of FPGA and what are the functions of each and every parts of that particular architecture. So this will be detailed inside this particular program. So therefore, whenever we are going for that field programmable gate array, the program can be applied in multiple sections like VHDL, HDL, even C program. So most of that particular FPGA systems will be working with HDL only. So once whenever we are working with this kind of different sections, so the FPGA consists of what and all the different parts like CLB or switch matrix, and at the same time interconnections. So these are all the main parts inside that particular field program gate array. So this particular FPGA, whatever we are providing or whatever the program is done inside the chip, so that chip here we will be enabling for only a single purpose. For example, if you are taking the difference between both microcontroller and FPGA, then you will get a clear idea on it. So microcontrollers features are nothing but it will be acting as a mini computer, whereas FPGA only for specific logics only they will be applying it. For example, if they are using that FPGA for IoT, then only for that purpose they will be using it. Whereas initially the Spartan 6 or the Spartan different versions, they are having different variants. So according to the variants only, the board is also selected over there. The same thing if you are going with Zinc 7000 series processor means everything is possible inside that particular single processor. So that is the capability of that. So once whenever you are going for the microcontroller, it acts as a built-in mini computer, whereas FPGA for only a specific logical blocks. Then next, if we go for the power consumption, FPGA consumes more power. At least 12-volt adapter with 1 amps you have to provide it. At least. Okay, and maximum we can provide with 2 amps. Then next, if we go for microcontroller means 5 volt is more than enough. Okay, if you are providing the Arduino with an adapter means 9 volt. If you are providing the USB power supply, 5 volt is enough. If you take Raspberry Pi means 5 volt is enough. Okay, then next, microcontrollers are built ready over there. We no need to design anything inside that, because we can take the microcontroller, we can dump the code, we can connect the interfaces, and we can execute it. Even the same way also for Raspberry Pi, we have to dump the OS, we have to install the package, we have to call the pin numbers, collect the connect that particular respective sensors, and we can execute it. But inside this FPGA, we have to make a restructured design over there. Inside the microcontrollers, restructuring it's not possible, whereas in FPGA it is clearly possible. And the other kinds of reason many of them are not selecting this FPGA projects, the other process regarding the cost of the processors, because FPGA is much costlier while compared to the microcontroller. So once whenever we just provide this kind of functions, here we have to analyze why they have designed in this way. So this is nothing but known as the FPGA's architecture. So here, what are the commons while compared to the controller as well as the particular FPGA means the IO block is almost same, and if you go for interconnect, that is also same, and switch matrix that is rarely applied. The switch matrix will be applied only for the IO blocks. Okay, so here whenever we just go for this kind of FPGA sections, here we have to just arrange in the form of different manners. Okay, so first we have to select the main processor. So here I have explained you that zinc 7000 only we are going to use, but for which board purpose? Because inside the zinc 7000 itself there are many boards like Z board, Atrix, and if you go for pink, and there is another one board named as edge. So these and all the different variation. So for that particular board, here we have to design. So generally, what and all that particular specs we will be having for each and every boards means like HDMI connections, VGA connections, serial communications, Wi-Fi protocol, Bluetooth, and if you go for LED interfacing, LED and 7 segment display, this and all comes under for input output blocks only. And whereas the ESP, Wi-Fi, and Ethernet and all, whatever we have said, it comes under the interconnection process. So in this ways only here we will be checking for each and every purpose. And one more advantage, if we go for this 7010, it is also possible to work under the Linux OS. So this Linux OS is directly provided by Xilinx itself, known as Pink. So Pink, one of the board, only uses this Xilinx 7010 and 7020. So these are the particular difference. That is nothing but the RAM and some small speeds only it will be varying within the processor. But that particular hardware, it is capable of working with OS and without OS. Both of them it is possible. Whereas if you go for Raspberry Pi without OS, it is not possible at all. If you dump a Linux OS only, it will be able to proceed. The same thing, if you go for Arduino, the Arduino you will be able to connect only with the help of Kale, or at the same time you can use Arduino IDE. But here for this FPGA, we can access in multiple ways, either with MATLAB, or Xilinx has multiple softwares like ISE, Vivado, Whittle. So these are all some of the softwares widely used for this particular process. So inside that particular FPGA, these are the four important things such as IO blocks, logic blocks, interconnect, and switch matrix. Then IO block. So once whenever we are going to IO block, it is very simple to collect the data as input as well as to send the data as output. So for both the particular process, whichever the pins we are using, that is known as IO block. So once whenever we are working regarding towards this IO block for connecting the sensors or for connecting the motors, relay devices, for that kind of purpose only, here we will be using. So this IO block is known to everyone. It doesn't have any of the special functions, because those who are having a basic knowledge on microcontroller, definitely sure they will have an idea regarding the IO block. Once again, I'm repeating, this particular block, it is used to connect the sensors and its peripherals, which stands for both input process as well as output process. So this is nothing but the architecture of IO block. So here inside this particular FPGA logic, once whenever we are working regarding towards this, the logic 1 and logic 2 can be deserialized for the functions of delay purpose. And at the same time, here we will be able to connect with multiple sections like DAC and ADC. So like digital to analog and analog to digital. So within that particular physical pad, whatever the functions we are connecting, it works similar to the functions of ARM controller. ARM controller or ARM processor. So similar to that, we will be having the separate architecture, and from that architecture, we will be taking that IO block alone, and from that IO block, according to the system, whatever we connect, let it be take an example like connecting a button to turn on that particular LED means. So therefore, here we have two sorts of pins. One is for LED and another one is for the button. But here button will be acting as input and the LED will be acting as output. So therefore, here we have to select that particular tile which works under the sections of master as well as the save. Okay. So here master, which one we will be selecting, because the master should be selected only for that particular kind of button, because based on buttons conditionally the slave should be working. So that particular slave, it will be automatically taking as an LED. So that's why only the simplified block diagram is applied for this master as well as slave. Why the expanded block diagram is not displayed over here means, because for that there are some sort of blocks which will be separated for master as well as slave, and at the same time which cannot be easily related towards the interconnection. So one of the interconnects, actually here we have seen the four sections in this architecture. Among this interconnect, it is a feature which connect all the other blocks. Okay, once again I am repeating, this interconnect feature will be connecting all the other blocks. So for that purpose only the interconnection is being used. There is no separate diagrams or there is no separate explanation for that. Okay, so here this particular IO will be getting the data or transmitting the data, and from that here we will be interconnecting with the FPGA's logic. So based on this only that particular logic will be integrated over here, and from that only the processing or the controlling sections, everything will be taken. Next, the most important part, configurable logic block. So here you might have seen in that particular architecture the logic blocks. So that logic blocks only called as CLB. The most important part or the hardcore of this particular part is known as configurable logic blocks only, because whatever the data you guys are collecting in the form of input or output, the logics whichever it is rewriting or configuring according to the system, it is done with the help of the FPGA logic parts. So here that configurable logic part will be generating in the form of two 16-bit, like 8-bit, 8-bit. For function it will be taking as 8-bit, and generator it will be taking as 8-bit, F or G. So based on that particular function sections only, here we will be able to apply it, and therefore here we will be having two more registers known as flip-flops or latches. So whatever the data here we are providing, this logic can be reprogrammed according to the situation. So from that particular situation or the integrations only, here it is taken as the FPGA cell, which is one of the most important FPGA cell over here. So from this FPGA cell, the logics will be automatically calculated according to the input whatever has been provided or the programmed by the person. So whatever we are designing that particular FPGA, the processor integrated with any of its inbuilt sections with the program which has been provided in C or HTL, because whatever if we write it in C, that is also converted into HTL over here. So that particular function will be taking place each and every kinds of sections. So here that particular conversions or the changes, it is easily applicable. So for that only many of them are choosing this kind of FPGA boards for testing with many of the embedded sensors or applications. Whereas if you go for that particular controllers means you won't be able to change any of the design. Other than the pins, there are no kinds of sections which we will be able to change. The program changing, it is only for the purpose of that interfaces, just to check the logics of the program only. But if you go for FPGA means the structure itself we will be able to change. Either its clock speed, either its function. So because all the boards they will be providing only with the high capacity. So within that range of capacity, for example, whatever the board I have said, let it be the pink or this particular Xilinx 7010, everything it works only with the help of 1,15,200 baud rate. So that will be that particular baud rate region. So from that particular baud rate region only, here we will be able to communicate between that particular device. So with that particular device, it is also possible to process the deep learning systems, and at the same time, whichever we apply it in multiple sections through Ethernet or through the Linux or beta network connections. So the architecture of configurable logic block. So here we will be having the four inputs, one reset and one clock, and here we will be having the mux. So the four inputs will be given as input towards the block, and from there the block will be highlighted into uh, two different formats. So one is for a D flip flop, that is for reset as well as the clock. So generally this particular flip flops are used to inverse that particular function in case any of the triggering or any of the batches that has been occurred. So for that particular patches, the flip flop will be able to make it up automatic sections, and from there here we will be able to take into the mux. So mux is nothing but multiple sorts of input converting into a single output. It is also known as multiplexer. So from this particular mux, here we will be taking the inputs from A, B, C, D. So that particular input output block, it will be just converting into that a group of data. So that group of data, if any problem is there, it will be directly provided to the flip flop. So from that flip flop, automatically the reset function takes place, and the clock, it is nothing but to calculate the clock speed of the complete process. So once after the flip flop process, in cases if it is necessary in the sense, so based on that only the particular mux also will be acting. So from that it will be collecting the group of data, and therefore it will be sending into the single output. So that particular single output, it may be any of the video display or serial data or any of the IoT data. It depends upon the application. So this is one of the blocks for CLB. This is one of the simplified blocks which I have collected for CLB purpose. So guys, if you have any doubts till this, you can just post it in chat. And I hope for everyone it is audible. Okay, so I hope there is no doubt regarding this. Oh, there are some questions over here. FPGA is volatile. FPGA technology independent. Very good. How to know that IO pins? Definitely for each and every board, Xilinx itself have provided their data sheets. So data sheets references must to know the pins and its names. So everything is listed out over there, and I hope that is clear for Mr. Abhishek Pathak. FPGA for create vending machines. Yeah, definitely it is possible. It is possible to create vending machine using FPGA. But once whenever you go for the cost wise, most of them will be opting into using microcontroller. Yeah, thank you, Ramani ma'am. Yeah, thank you, Sakti Studio. So I hope you guys are able to process it out, and I hope still the comments are receiving over here. And there is one more interesting question, Mr. from Pragati Raja. What is LUT? LUT is nothing but lookup table. The flip flops or the functions whatever we are providing only is according to the table oriented data only. I am not sure that how many of them has gone through the subject of digital logic circuit. That is the most entire basic for both embedded as well as VLSI. So before going to that VLSI or embedded major topics, I suggest you to go for digital logic circuits. I think many of the books are also available. Definitely, it is completely theory. There won't be any of the practicals over there. So with that particular reference, here we will be able to come to know what is mux, demux, how the flip flops are applied, how many types of flip flops are there, and some basic HDL programs also will be there in the digital logic circuits. It is also known as DLC. And at the same time, after that, based on your interest, you can move upon towards embedded or VLSI. Okay, so I hope everyone is clear with that particular explanation. Okay, even Mugeshwari ma'am is also supporting me as a chat assistant. Thank you, ma'am. Thank you so much. And due to the network issues, I'm receiving the updates as delay. And kindly, everyone can change your resolution to 720 pixels so that you can see that particular block diagrams as clear as possible. So here we have streamed it in 720 pixels only. If it is in auto mode, definitely it will goes for 144 pixel only. So kindly check your resolution. Okay, so I hope everyone is clear with this. Next, the switch matrix. So generally, the switch matrix, the name itself, it is known as the switch matrix, like the number of transistors which are we have placed inside the FPGA. So to switch that particular according to the logics. For example, if you are connecting the multiple devices or multiple motors, if I want to turn on the motor one, therefore only that particular matrix will be turned on. If I want to turn off the motor 1 and turn on the motor 2, then therefore that particular two switches will be working over there. One is for turning off and another one process for turning on the second motor. If I want to work on both at the same time, means both the gates will be opened. So this kind of functions, it is taken only with the help of the transistors, and for that particular transistors here we can use this switch matrix. So that particular switch matrices, it is defaultly available inside the FPGA when that particular IO blocks connected with configurable logic blocks using an interconnect. So in that particular interconnect only, here we can see that complete sections of a switch matrix over there. So based on the logic, the matrix will be switched and therefore the input output action will be taken. So definitely for input side means input will be the first. If you are going to provide the output means based on that particular input traveling to the CLB and from CLB to switch matrix. So based on that particular CLB's logic only the switch matrix also will be acting. For interconnecting all these functions we will be using interconnections. So for this there is no such kind of block diagrams or anything. So for that switch matrix, you can view it in this itself. So this green colors are intimating it as switch matrix, whereas the lines are nothing but in the form of interconnect. So here it has been connected inside the matrix form, like 4 cross 4. So that particular 4 cross 4 matrix form means it is very easy to turn on the switches and turn off the switches for each and every blocks whichever we have to go. And at the same time, here you can see only the 4 cross 4 means it stands for the 16-bit application. Okay, so now let us move towards the Xilinx. So Xilinx does nothing but it is famous for that particular FPGA creations. So definitely, if we go for the processor-based sections, means we have many processor industries like Intel, AMD, Nvidia. Then nowadays, Asus is also working for the processor based. And if you go for the mobile processors, means Snapdragon, Qualcomm, Bionic chip from Apple. So these are the different types of processors nowadays available. Among that, Xilinx is one of the industry which provide this particular processor only for the purpose of FPGA, and many of them are using it as a test kit or application kits over here. So this particular FPGA, which consists programmable SOCs, whatever that configuring or providing the input output, it is completely worked only in the basis of SOC. And at the same time, once whenever we are working with this SOCs, here we will be just integrating multiple functions as cars and clouds. And if you go for mobile phones, means integration between the mic and camera. So like the kind of much functions are provided. And at the same time, once whenever you are working in this Xilinx, means it is very satisfied kind of testing, or which is good for studying also. And most of the applications with the help of Xilinx, it is nothing but automotive based applications only, which initially we might have heard that particular functions like CAN or SPA protocols and all. So that particular CAN SPA protocols, everything is uh, compiled into a vehicle or automotive oriented functions. So it is completely done only with the help of this kind of Xilinx FPGAs only. Why I am saying that it is completely acquired for Xilinx FPGA means most of them had might have been heard that CAN protocol, everything works under the ARM 7 or ARM 9, like that kind of controllers. The thing is nothing but whatever the CPU that is providing the support for this particular FPGA, it is nothing but the ARM. So that too ARM Cortex range only here it will be supporting, and the version is A9. So from that particular A9 implementation only, here we will be able to integrate this kind of field programmable gate arrays. So based on that, the programs, the gate arrays will be automatically changing. So for that, for each and every supporting purpose or the processing units, it is completely done with the help of ARM Cortex. Okay, if we go for the Xilinx family, here the Xilinx family can be separated into two types. So those two types are FPGA without CPU and FPGA with CPU. So FPGA without CPU means the XE series, Spartan, Atrix, Vertex, and Kintex. So these are the multiple boards that is available without CPU. Inside this, you guys will be receiving only the Xilinx chip. There won't be any other processing units over there. And once, whenever I have said some of the examples like deep learning, machine learning itself, you might have thought how the FPGA is possible to work with that. So that is only with the help of the CPU's architecture, which has been integrated to Zinc. And if you go for FPGA CPU, FPGA with CPU means only two possibilities: Zinc 7000 series as well as Zinc Ultra Scale. So this kind of boards only it is widely used, and these boards are much costly also. So for if we go for the Zinc 7000 series means 7010, 7020 are the name of the chips, which can also be called the board named as Pink 1 and Pink 2. And at the same time, if you go for the ultra scale boards, means you can go with Z board. And even that, in some rare versions of Arctics also have some minimum CPU applications which cannot be applied for deep learning or machine learning, but it can be applied for signal processing like a 5G testing center. Whereas if we go for the Zinc 7000 series, means it is applied for all the IoT, MLDL, image processing, everything can be applied over here with the help of the OS. There we can also work it with the help of Jupyter Notebook by using the Python programming. So these are the different boards that is available inside the Xilinx family. Once whenever you are selecting the boards itself, you will be able to understand. So these many boards are there. So which board should be selected? Select that. And the cost of that particular FPGA with CPU means it will cost starts from 17 to 18, and the higher is 25, 25 or 30. I'm not sure. So these are nothing but the different applications of, I mean, the boards available from Xilinx. So I hope everyone is clear with this. Next, Zinc 7000 series. What are the applications of the 7000 series? And what are the difference and what are the set of boards available in 7000 series? So for that particular description only, and this particular description, it is taken from the Xilinx site itself. So like the 7000S, it completely works with the single core ARM processor as a CPU. And just note down that particular size is 28 nanometer of processor, and from that, what and all the boards are available means ATIC 7 and Zinc 7000 platform. So it have an capability of transmitting and receiving of 6.25 GB data. So with the help of the transmitters or receivers by using the Wi-Fi, or at the same time we can also go with Ethernet speed of data transmission also. So this complete section, it is used for 7000 S model. In 7000 we have two model, one is S and another one is without S. What are the applications this particular board has been transmitted for? Multi-access motor, machine vision, programmable logic controller. So these are the different applications which has been created with the help of Zinc 7000S. Then if we go for the Zinc 7000, so what are the features while compared to the S means? If that particular S series has the function of 6.25 GB means 7000 have, which starts from 6.25, and the highest is 12.5 GB per second. So that is the reason we are able to process even a deep learning data with the help of the Zinc 7000. So here the logic cells will be created for 6.6 megabytes, which offers that particular range from 6.25 to 12.5. And the output can be easily visualized with 4K, 2K, Ultra HD. We can also say it as starts from 720 pixels. It starts from 720 pixels. So till that resolution, we will be able to make it. And many of them will be thinking like, if I have said that particular Linux OS, so therefore that particular Linux OS means it is not like an Ubuntu and all. We have to work with the help of Putty. So through Putty only we'll be able to collect all the data or implement all the data over there. So through that Putty we will be taking that particular port number, and through web browser we will be working with each and every installations, and at the same time integrations of image processing or deep learning sections. And this video input and video output can be easily provided with the help of any of the monitors which has an HDMI or VGA connections. So the applications of the 7000 series are like ADAS, medical endoscope, small cell baseband, professional cameras, machine vision, carrier Ethernet, backhaul, multifunction printers. So inside this, I hope ADAS is most familiar for everyone, I think so. ADAS is nothing but advanced driver assistance system. Some of the systems which has been created with the help of Tesla's autonomous car, that it completely recognize the 3D or the particular 2D visions also. Based on that, it is able to take a decision like slow the speed of the vehicle or overtake that particular vehicle. So like that kind of functions and all, they will be using this Zinc 7000 processor only. And from this particular family only, we have chosen as 7010. So what are the specs of Zinc 7010 means? The processor, it has been created by using A9 ARM Cortex, which is dual core, and the co-processor, the supporting section, it is created with the help of Neon A chip with single and double precision, and the level 1 cache of 32 kb and level 2 cache of 512 kb, which stores this much kind of cache data, which is widely used for IoT purpose. And it has an on-chip memory of 256 kb, and if you're going to work with the OS means, you can add a 32 GB memory card. Then comes with the memory interfaces. So the memory interfaces, like it is available in DDR3, DDR3L, DDR2, LPDDR2, Quad SPI, NAND, and NOR. So these are the different SPIs available. Sorry, these are the different interfaces available, and these interfaces can be easily designed with the help of Vivado, and it can be executed in Vittel. So the continuation of that specs, like the peripherals, we are allowed to connect two OTGs. I mean, two USB ports are available, where we can also connect our USB camera, and at the same time SPI camera is also available. We have a port for Ethernet, and that particular logic cells are of 28 kb, and the block RAM is about 240 kb. So for signal processing, we have 80 slices inside this particular processor. Yeah, related to daily life processing only, here I have explained that autonomous car, because autonomous car, it is not only possible with the help of processor. So some sort of on spot logic checking also is required. So that is the reason they have combined this CPU as well as with that particular FPGA. Whereas whatever the training of data sets, that is done with the help of GPU to reduce the stress of system. And this answer is for Mr. Vibin Kichu. So guys, if you are interested in this particular webinar, so you can just share this particular video to your friends, and you can also provide a like to motivate our functions. So this is nothing but the architecture of 7010, and this is the maximum I will be able to maximize the image. So here you can see the main part of the core site. It has two particular kinds of processor. One is designed for FPU purpose using Neon, which is for digital signal processing, and at the same time here we have used the other input output caches for using ARM Cortex A9 series only here we have used, and the 512 kbs of byte for L2 cache, and at the same time here we have general purpose input output with watchdog timers. Everything is inbuilt inside the processor. So definitely we won't be able to edit that particular kinds of functions whichever it is present, but these many functions, from that we will be able to select the required one. So whatever the specs I have given in a theoretical format, everything is available in this particular architecture diagram. So wherever you are seeing that particular green, that denotes interconnections. In architecture, we won't be able to see the CLB and switch matrix. Those are set as the inbuilt functions. Okay, so I hope everyone is clear with that. And now let us see how easily we can start a project. So this is just a complete basic kickstart. Should I have shortened the theory? Still, there are many theories. We have not gone through ARM itself because it completely works on the basis of ARM. So here, once whenever you open this particular Vivado, the first option is for creating the project. So click on the create project. Click on next. So here we have to provide the project name, and here I have given some project locations. It will be taking default over there. So here we have to select which kind of sections we are going to take. So generally, if you want to create the block designs and IP integrator means we have to apply it with the help of IP generator with RTL. If you want to use that particular Vitus platform, you have to enable that. So click on next, and from here we have to select the required board. So here I have a separate board from all about FPGA. So in parts it is not available. Yeah, so here it is available. So this is the board whichever we have. So this board only I'm going to select. So select that particular board and click on next. So RTL project, and these are the specification of that particular board, and click on finish. And finally everything is created. Okay, so from this only, here we have to move on towards our block creation. From this IP generation, so the name is design one I'm going to provide. Those are all default name. If you want means you can just change it. Okay, so now therefore we have taken that particular block designing area. So here we have to select the add IP, and based on our input we have to select it. So for now we will see adding the zinc processor. So here, if you want to just validate the design and at the same time create any of the ports, or if you want to check any of the properties of the block, everything it is possible. Okay, so this is the main particular processing we will be using it on. And like this, here we can add some more IPs like DMA, direct memory access for video purpose. This particular direct memory access, here we will be using it for the purpose of HDMI section. So the watchdog timer to apply the delay time. Okay, so in this basis only, here we'll be designing this FPGA. And after just dragging that particular designs over here, we can directly move to the window, or we can provide this run synthesis. So from this run synthesis, the entire bit stream will be created, and after that, by using this Vitis IDE, we will be able to simulate it. So due to less storage in the system, it won't be able to open the Vitis. So in this way only, here we will be working with FPGA system. So definitely here we are planning to conduct FPGA sessions in a series. So from the next sessions, we will be seeing like how the board is being integrated and how we are able to execute a particular property inside the board. Yeah, I'm happy to hear this kind of multiple good commands over here individually for each and every person. I'm thanking on behalf of Pantech-e-Learning. And guys, if you have any doubts on this, you can just post it. If anybody has doubt, you can just post it in chat. Yeah, thank you so much, Hariharan Narayanan sir. Thank you, Muriyeshri ma'am. How to get the power area delay reports for particular board? Yeah, for that we have to test with that particular board with the help of input data only. So like if you are just calculating the power area means, so how much amount of power or the consumption of power for each and every kinds of input. So that particular section only here we have to create it. So for that we can consume it based on using the current or voltage sensors. So that will be good for testing purpose. Whereas inbuilt we won't be able to collect any of the data. Yep. So any doubts regarding this, you can just post it. And for more queries and upcoming webinars update, you guys can follow us on pantechelearning.com. Once again, I thank Saveetha College of Engineering and Technology for providing this wonderful opportunity. And many of them are thinking that VLSI it is some of the old kind of technique. But in my perspective, uh, VLSI it's still trending. So even if you check out for the jobs, there are many vacancies, but they are recruiting for experienced persons. That is entirely different. But if you are interested in this, please carry on in this, because even ARM also has recently released their boards for multiple sections, but till now many of them are not updated. So in this platform, I would like to share this particular knowledge, because most of them are avoiding this ARM based projects or ARM based learning or VLSI FPGA learnings and all. Only the reason those are little bit complicated and it takes many time to learn. So kindly, those who have interest in this, please try to carry on now itself and use this particular lockdown period so that you can learn more and more. For self practices, it is better to purchase a board, because that will be providing you a greater experience. Yes, attendance link is pinned through the live chat, and at the same time it is available even in description box. And I hope everyone has enjoyed this particular session. So next time when we meet with FPGA, we will be working with that hardware interface. And okay, guys, thank you all for your support. Once again, I thank Saveetha College of Engineering for providing this wonderful opportunity. So thank you all. During this pandemic period, stay home, stay safe, which is the best medicine for us. Okay, guys, thank you all.